Hey y'all, welcome back to another Leetcode video where I go over problem 242, which is valid anagram. It is an easy problem, so to get right in, we're given two strings s and t, and we return we return true if t is an anagram of s and false otherwise. And then we're given the description of anagram, which is if you rearrange the letters of a different word, then it should scramble back to the original letters exactly once. So we're given an example here. If you have anagram for the S string and then T as nagram, I'm not sure if I pronounced that correctly, but yeah, we return true because for each letter we have three A's here, we have three A's here, we have one N here, we have one R here, one G here, and one N. So this is a valid anagram. We return true. In example 2, we're given the opposite. We return false because we have one R, one A, one T, but in here we have one R, one A, but we have one C, and this letter does not have this. This word does not have the letter C, so we return false. They are not anagrams of each other. Okay, so to kind of approach this problem, I'm thinking we need some sort of way to kind of track a counter for each individual letter in the word, how many times it appears in that word. So if I was given the word, let's just use anagram again as an example. We need some sort of data structure, or we can just have, A is appearing 3 times, N appears 1 time, R appears 1 time, M appears 1 time, right? There you go. So for each individual letter we map out and we have a counter of how many times it appears in that word. Same with, let's say, noon, for example. N is appearing 2 times, O is appearing 2 times. There you go. So I'm going to use Python for the solution, but you can use any other language, Java, JavaScript, whatever you want. But yeah, so we need some sort of way to do that. And to get to this, I'm going to be using a dictionary data structure here. So I'm going to initialize 2 empty dictionaries, one for the S word and one for the T word respectively. S dictionary, T underscore dictionary. Initialize 2 empty dictionaries. Oh. And then we also need to think about a different scenario, right? In both of these examples, the length are the same, so they pass that check. But if you're given, say, S was equal to noon, and then T was equal to burger, these two would automatically be false, right? Because the length of this word is 6 letters, while the length of this word is 4. So we can immediately return false because it wouldn't even be a question of if they were anagrams of each other, because we first need to check if the length is the same, and then we can move on and individually map out each letter and check if they have this same count for each letter. So yeah, so we can just write that simple logic here. If the length of S is not equal to the length of T, then we just return false. So we fix that scenario. And one other scenario, I don't know, something with my white spacing is kind of weird for some reason. Okay, yeah. Oh, wait, no. Okay, am I tripping? I'm so sorry. Oh, okay, that was the issue. Okay, yeah. Another scenario is, let's say if we're given 2 words that if you read them left to right, they're the same as right to left. So like race car and like I said, noon. If you read them left to right, they go R-A-C-E-C-A-R. If you read them right to left, they go the same way, R-A-C-E-C-A-R. Same with noon. If you read it N-O-O-N and N-O-O-N, left to right is the same as right to left. So we can do that the same. So elif, if we're going backwards, reading from right to left, the string of S is equal to the string of T going the normal way, which is left to right, then we just return true. There you go. So we fixed 2 scenarios, reading left to right is the same as right to left, and checking if the length of both strings are the same. Okay, now the actual main problem, like I kept saying, is tracking each individual amount of letters and how many times they appear. So what I'm going to do is, this would actually be the time complexity of the solution would be O of S plus T, because I'm going to be looping through each individual word and then adding them to the dictionary, the count for each. So yeah, that's kind of the time complexity of the solution. It's, I'd say, moderately fast, but it's not very memory efficient, I'd say. It's pretty bad at memory. But yeah, this is my solution, how I did it. So anywho, moving on, I'm going to be looping through each individual letter in the string S. And if we already have that letter in our dictionary, then what we're going to do is we're going to increase that count of the key respective to that letter and increment it +1. The dictionary += 1, accessing that key. And if we don't already have that letter in our dictionary, then we're just going to add it and initialize it equal to 1. We're going to be doing the same thing for the T dictionary. Yeah. Okay, now that we've added the count for each individual letter, which is basically just this drawing right here, count right here, now we're going to compare if the count for each letter in S is equal to the count for each letter in T dictionary. So let's write that logic. So we're going to loop through each kind of key in the T dictionary. And if there is a key in the T dictionary, it's the same as the S dictionary. And then we'll write another if statement under that. We access the value of that key in the S dictionary, and we check if that's equal to the value of the key in the T dictionary. And if they are true, then we'll continue. That means we continue a new loop. That means that key passed, and then we go on to the next one. We keep going until we don't actually meet this conditional statement to value it to true, and then we just return false. And if this loop does actually return work and everything just sounds good, then we just return true at the end. So let's see how that runs. Oh, did I not? Oh, sorry. Looks like the one equal sign. There you go. Not sure if you can actually see, submit it, but yeah. Submit the solution, you can see the time complexity, speed, and the memory usage. So yeah, it is actually, I'd say, fairly fast. Memory wise, yeah, it's pretty, I'd say, moderate. It's pretty good. It's cool. But yeah, that's how you do it.